This is a NEET 2016 question from rotatory dynamics. The problem is like this. A disk and sphere of same radius but different masses roll off the inclined plane of the same altitude and length. Which of the objects will reach the bottom first? So the question that was being asked is, there is an inclined plane. From the top of the inclined plane, a disk as well as the sphere are rolling down like this. So it has both translatory motion and rotatory motion. At the angle of inclination is theta, height is h, length of inclination equal to L. At this point, it is all having potential energy. By the time it reaches the bottom, it has only translatory and rotatory kinetic energy. So the total energy is conserved. So total energy at the top equal to total energy at the bottom. At the top, when a particle is there of mass m, total energy is only potential energy mgh. When it reaches the bottom, it has translatory motion, translatory kinetic energy, and of course rotational kinetic energy half I omega square. I can convert this half I as mk square, where k is radius of gyration, omega square as v square by r square. So half mv square can be taken common, 1 plus k square by r square, where k is radius of gyration equal to mgh. For the body's mass can be cancelled. So I can write an equation for v square as 2gh by 1 plus k square by r square, or v as square root of 2gh by 1 plus k square by r square. But of course, if h is not given, here I can write sine theta as h by L. That implies h becomes L sine theta. So we also can be written like 2gl sine theta by 1 plus k square by r square. After deriving an expression for velocity on reaching the bottom of the inclined plane, I can use v square minus u square equal to 2as. V square means this, that is 2gh by 1 plus k square by r square minus u square equal to 0, starting from the state of rest. 2a, s is nothing but equal to L. This is the distance that the body has traveled. So I will convert this h also into L as L sine theta. So in the place of h, I will write L sine theta. So 2gl sine theta by 1 plus k square by r square equal to 2al. 2 and 2 can be cancelled, L and L can be cancelled. Thus, acceleration of the body sliding down the inclined plane is g sine theta by. I could have directly solved the problem, but I am just deriving this formula so that you can use them at any of the later stage. I have derived equation for velocity. I have derived equation for acceleration. I can also, but our question is anyway is who will get to the bottom first? That means we need time. From here, we can calculate time quite easily using our regular formula S equal to ut plus half at square. As they're all coming from the state of rest, S distance traveled is L, u equal to 0 half a t square. So t equal to root 2L by a, where acceleration equation we have derived already. So how much is that? Root 2L by a means g sin theta by 1 plus k square by r square. So time to reach the bottom is root 2L by g sin theta of denominator comes to numerator 1 plus k square by r square. As these all terms are constants, it's very clear time is directly proportional to 1 plus k square by r square. For a disk, moment of inertia is mr square by 2. I can equate that to mk square. That implies k square by r square is 1 by 2. That is 0.5. For a solid sphere, moment of inertia is 2 by 5 mr square, which can be equated to mk square. That implies k square by r square is 2 by 5, 0.4. So T of solid sphere by T of disk is directly proportional to square root of 1 plus k square by r square for the solid sphere is 0.4. 1 plus k square by r square for the disk is 0.5. That is square root of 1.4 by 1.5. Obviously 1.4 is less. The solid sphere takes less time. So sphere reach bottom first. Solid sphere reach the bottom first. That's how we have to solve the problem. Though the problem looks like lengthy, it's lengthy simply because I have derived all these equations. If I have set these equations, you could have directly come from here and solve it. But I just want to make sure that he shall know from where these formulas are coming. Therefore, problem need not be next time this. It could be some another problem somewhere who will have more velocity, who will have more acceleration. To solve those kind of problems, this derivation shall help you. That's why I have derived them. Please go through and learn the derivations. Thank you for watching.